Accounting Information Systems, Week 2. Chapter 4, Learning Objectives. Read and evaluate data flow diagrams. Read and evaluate systems flowcharts. Prepare data flow diagrams from a narrative, and prepare systems flowcharts from a narrative. Data flow diagrams. A data flow diagram is a graphical representation of a system. It depicts the system's components, the data flows among the components, and the sources, destinations, and storage of data. It uses a limited number of symbols. Physical data flow diagrams are graphical representations of a system showing the system's internal and external entities, and the flows of data into and out of these entities. It specifies where, how, and by whom a system's processes are accomplished, but it does not specify what is being accomplished. A logical data flow diagram, a DFD, is a graphical representation of a system showing the system's processes, as bubbles, data stores, and the flows of data into and out of the processes and data stores. It specifies what activities the system is performing without specifying how, where, or by whom activities are accomplished. Logical DFDs portray a system's activities, while physical DFDs depict a system's infrastructure. A systems flowchart is a graphical representation of a business process, including information processes as well as the related operations processes. It depicts the sequence of activities performed as the business events flow through the process, and gives a complete picture of a system by combining the physical and logical aspects. Preparing data flow diagrams involves analyzing the narrative, creating a table of entities and activities. Remember that an activity is any action being performed by an internal or external entity. There are actions related to data: send data, transform data, file or store data, retrieve data from storage, or receive data. There are also operations process activities, which include picking goods, inspecting goods at a receiving dock, or counting cash. Please keep the following in mind when flowcharting systems. First, strike a balance between clarity and clutter by using annotation judiciously and on-page connectors whenever flow lines create clutter. Avoid crossing lines whenever possible. If you must, use a bridge. Finally, document only normal routines and leave exception routines for another page of the flowchart. Chapter 5, Learning Objectives. Describe the limitations of traditional application approaches to managing data. Analyze the advantages gained by using the centralized database approach to managing data. Create normalized tables in a relational database. Use entity relationship diagrams in database design and implementation. Explain the importance of advanced database applications in decision support and knowledge management. A database management system is a set of integrated programs designed to simplify the tasks of creating, accessing, and managing a centralized database. A database management system integrates a collection of files that are independent of application programs and are available to satisfy a number of different processing needs. A database management system supports normal data processing needs and provides data useful to managers. The advantages of the centralized database approach includes the elimination of data redundancy, ease of maintenance, reduced labor and storage costs, data integrity, data independence, and privacy. There are disadvantages to the centralized database approach. For example, such an approach is expensive to implement and maintain. If the DBMS fails, all of the organization's information processing halts. There is increased potential for damage should unauthorized access to the database occur. Finally, database recovery and contingency planning are more important than in the applications approach. Decision support systems are information systems that assist managers with unstructured decisions by retrieving and analyzing data and generating information. Such a system possesses interactive capabilities and can answer ad hoc inquiries. It also provides data modeling facilities, such as spreadsheets, and can imitate human decision-making, i.e., artificial intelligence, when confronting complex and ambiguous situations. Executive information systems, on the other hand, also called executive support systems, combine information from the organization and the environment, organize and analyze the information, and present the information to the manager in a form that assists in decision-making. Most have highly interactive graphical user interfaces. They are mainly about collecting and presenting information to executives and less about doing processing and calculations. There are group support systems as well. A group support system, also known as a group decision support system, is a computer-based system that supports collaborative intellectual work such as idea generation, elaboration, analysis, synthesis, information sharing, and decision-making. Such a system supports brainstorming, which is a method for freely and creatively generating as many ideas as possible without undue regard for their practicality or realism. Expert systems and neural networks. Expert systems are decision support systems for complex decisions where consistency is desirable and the decision maker wants to minimize time and maximize quality. Such systems emulate the problem-solving techniques of human experts. Neural networks, on the other hand, are computer hardware and software systems that mimic the human brain's ability to recognize patterns or predict outcomes using less than complete information. Data warehouses and data mining consists of the following. Data warehousing is the use of information systems facilities to focus on the collection, organization, integration, and long-term storage of entity-wide data. Its purpose is to provide users with easy access to large quantities of varied data from across the organization to improve decision-making capabilities. Data mining, on the other hand, is the exploration, aggregation, and analysis of data in data warehousing using analytical tools and exploratory techniques. Knowledge management systems, on the other hand, is the process of capturing, storing, retrieving, and distributing the knowledge of the individuals in an organization for use by others in the organization to improve the quality and efficiency of decision-making across the firm. Knowledge refers to information that has been formatted and distributed in accordance with an organization's routines, processes, practices, and norms. Here are the Chapter 6 learning objectives. Understand basic aspects of business intelligence and appreciate its importance to the business community. Understand the techniques used to model complex accounting phenomena in an entity relationship diagram. Develop ER diagrams that model effective accounting database structures using the resources, events, agents approach. Recognize the components of relational tables and the keys to effective relational database design. Understand the use of structured query language commands to create relational tables during implementation of the model. Manipulate relational tables to extract the necessary data during decision-making. Business intelligence uses state-of-the-art information technologies for storing and analyzing data to help managers make the best possible decisions for their companies. BI systems are specifically designed to support managers in making tactical and strategic decisions. Business intelligence is often installed into an existing ERP as an additional module. Relationships. Relationships are associations between entities. Entities must be logically linked to show relationships. Mapping of relationships between entities, i.e. the development of the ER diagram, provides a roadmap for getting from one piece of data in the database to another related piece of data for extracting data from the database. Please keep the following considerations in mind when devising a strategy for identifying relationships that should be included in a model. Identify users' information requirements to determine if relationships in the data model can fulfill them. Evaluate each of the entities in pairs to determine which entity in the pair provides a better location to include an attribute. Evaluate each entity to determine if there is a need for two occurrences of the same entity type to be linked. Despite a push toward object-oriented databases, relational database-driven legacy systems exist in most large organizations. The effort to switch them over to object-oriented databases is cost-prohibitive. Many legacy systems, systems that have existed in an organization over a long period of time and developed using an organization's previous computer hardware and software platforms, have been reliable for decades. SQL, the Relational Database Query Language. SQL is a powerful database language that can be used to define database systems, query the database for information, generate reports from the database, and access databases from within programs. It has become the de facto standard database language and has become so critical to many businesses that more and more software is being developed to help users generate queries quicker. Common SQL commands for populating the database. Create, generate the structure of the relation. Insert, enter current data into the structure. Delete, remove tuple from a relation. This requires specification of a table name and a where condition used to identify the unique tuples for deletion. Update, change one or more attribute values for one or more tuples in a table.